Section 4.2, to be able to translate the graphs of sine and cosine functions. First, we have to define what a translation is. And in trig, when we translate a function, it's actually called a phase shift, which means we're going to move the function to the left or the right, depending on what happens to the interior of the function. And the easiest way to do that is to take a look at an example. Recall that our general function for sine is y equals a sine bx. And in this instance, our b is going to be located in between the sine and our first set of parentheses. Our a is still located in front of the sine. The only difference in this function is that I have a minus pi thirds in the interior of my function. That's going to be my translation or my phase shift. From the previous section, we already know how to graph the sine function, and we're going to follow the same exact procedure here, assuming that minus pi thirds is really not in the problem. So the first thing we want to do is find the amplitude. The amplitude is the constants in front of my sine function. Here it is 1. So my amplitude is the absolute value of 1 or 1. My period is going to be just as it was on the previous section, which is going to be 2 pi divided by b. Here, the constant in front of my set of parentheses is 1, so this is just going to have a period of 2 pi. I also want to find the quarter point, and I'm going to follow the same procedure as I did before, and I'm going to take my period, which is 2 pi times 1/4, and then I'll simplify, so now I know my quarter point is going to be pi over 2. Now what I want to do is graph the function y equals sine x without the phase shift of pi thirds using the amplitude, period, and quarter point I just generated. The y-axis, the x-axis, amplitude of 1, and my quarter points. Pi over 2, 2 pi over 2 or pi, 3 pi over 2, and 4 pi over 2 or 2 pi. Now I'm just going to use the values for my sine function. Recall that we start at 0, and since it's positive, that will be an amplitude of 1 to the positive section. Back to 0, -1, and we finish where we started, which is 0. Then I generate a smooth curve. Let's take care of the function we want to graph, which is sine x minus pi thirds. To initiate, anytime I have an interior function, I'm going to set that interior function equal to 0 and then solve for x. That gives me x equals pi over 3, and that tells me that this is a positive value. That means I'm going to shift my line to the right. And so what I'm going to do is shift all my quarter points of 0, pi over 2, pi, 3 pi over 2, and 2 pi to the right by pi over 3. So I'm going to add pi thirds to each one of those 4 values and generate a point on each one of them, then generate a smooth curve using those values. So here, 0 plus pi thirds is pi thirds. Pi over 2 plus pi thirds. Common denominator is going to be 3 pi over 6 plus 2 pi over 6, which is going to give me 5 pi over 6. Then 3 pi over 3 with a common denominator for the pi thirds gives me 4 pi thirds. And then 3 pi over 2, but with a common denominator of 6 is going to be 9 pi sixths plus 2 pi sixths is going to give me 11 pi sixths. And then for 2 pi, multiplying the top and bottom by 3 is going to give me 6 pi thirds plus pi thirds, and that will give me 7 pi thirds. Each one of my quarter points moves to the new section. So from here, the 0 goes to the pi thirds. My 1 goes to 5 pi sixths. 0 at pi goes to 4 pi thirds, and the 1 at 3 pi over 2 goes to 11 pi over 2, and 2 pi at 0 goes to 7 pi thirds. And then I generate a smooth curve through those red dots. So the red line is the sine function shifted by a unit of pi thirds to the right. Now I'm going to verify my solution using the calculator. For my x min is going to be the negative period of negative 2 pi. X max is the positive period, which is going to be 2 pi. I actually generated it to be 3 pi to make it a little bit bigger. That's not a problem. My x scale is my quarter point, which is pi over 2, and my x y min is 1 greater and 1 less than my amplitude. So I'm using a negative and positive 2. Of course, remember my mode is in radian mode, and I generate the graph. And what I have is from the 0 over, which starts here and then goes to the intersection of 7 pi over 3. So from pi thirds to 7 pi over 3. And to verify that, I'm going to plug in second trace or calculate a value for, and I'm going to use 11 pi sixth, which should give me a negative 1. And it does. Therefore, my solution is correct. The next slide will state the procedure used to graph these phase shifts. I put this slide on our group resource page. So step 1 is factor the inside quantity to get the coefficient equal to a positive 1. Then set the quantity inside the parentheses equal to 0 and solve. I will show you the factoring in the next example. Then we continue by finding the amplitude. Then we go on to find the period. And then what we do is find the quarter point by using the period. Graph the function as normal with no phase shift, and then shift each point left or right depending on the equation solved in step 1. Connect with a smooth curve. Let's go to our next example. Y equals cosine 2x plus pi. In this problem, we see that inside my function I have a constant of 2 in front of my x value. And the first step on the last procedure stated I need to have my constant inside that function equal to a positive 1. Like our prior example, I had sine x plus pi thirds. X had a constant of 1. So our first procedure is to factor out the inside function. So y equals cosine, and what I'm going to do is factor the 2 out of that function. And when I factor the 2 out, that will give me 2x plus, and this will be pi over 2. Now you can check to see that you're right by distributing back in. That would give us 2 times x, or 2x, and that would give us 2 times pi over 2, which would give us pi. Now I continue with the procedure we're used to by graphing our function, and what I'm going to do first is find the amplitude. Our amplitude is the constant in front of my function, which here is going to be 1, so the absolute value of 1 is equal to 1. I'm going to take the 2, which is going to be used for my period, and remember that is going to be 2 pi divided by b, and here the b is 2, so that will give us a period of just pi. And then I'm going to take my period and I'm going to find my quarter point by multiplying the period by 1/4. So pi times 1/4 will give me pi over 4. Now what I want to do is graph, setting up my y-axis and my x-axis. That's going to give me pi over 4 is my quarter point, so I count by fourths. Pi over 4, 2 pi over 4, or pi halves, 3 pi over 4, and 4 pi over 4, which is pi, which is my period. Now, recall that cosine starts off my origin, and that starts at my amplitude of 1. So I have my first point at 1, and then I continue through the quarter points of 1, 0, -1, 0, and finishing what I started with, which is 1. Then I connect the points with a smooth curve. Now this graph represents y equal to cosine 2x, and this does not have the phase shift of pi over 2, and that's what I need to do, is to construct a graph that does have that phase shift. Now, the procedure to do that is to take the interior function, which is x plus pi over 2, and set that equal to 0, and then we solve. So that will be x equals a negative pi over 2. Since that value is negative, my function is going to shift to the left by the amount of pi over 2 at each quarter point. So the quarter points are 0, pi fourths, pi over 2, 3 pi over 4, and pi. And each one of those will subtract pi over 2 from, and that will give us the new points for the phase shift. So let's start. 0 minus pi over 2 will give me a negative pi over 2. Then pi fourths minus pi over 2, or 2 pi fourths, will give me a negative pi fourths. Then we have pi over 2 minus pi over 2, which will be 0. Next, 3 pi fourths minus 2 pi fourths, or pi over 2, will give me 1 pi fourths. And then my last one, which will be pi minus pi over 2, will give me pi over 2. Then every point will shift pi over 2. So the first point of 0 will shift to a negative pi over 2, and then we'll just repeat from 1 to 0 to negative 1 to 0 to 1. And then I'll graph that with a smooth curve. Verify this using our calculator. Y equals cosine 2x plus pi. And then what we want to do is set our window. Remember, our x min is going to be our negative period, which is a negative pi. Our x max is our positive period. Our scale is going to be our quarter point. And our y min and max are one above and below our amplitude. And then we're going to graph. Let's check a value. Second trace for calculate. We want to try a value. And let's try a negative pi over 2. And that should give us a positive 1. And it does. Therefore, our solution is correct.